Welcome to the Calculus 2 video. Today's video will be about Euler's method, a numerical method to solve first-order degree differential equations with a given initial value. The first question is, use Euler's method with 3 steps of equal size to approximate f of 2. The first question is, dy over dx equals x minus y minus 2, and f of 1 equals 3. Euler's method's equation is yn plus 1 equals yn plus the change of yn. The first point given is the x0 and the y0, which is -1, 3. To find the x1, you use the x initial plus the change of x. And to find the y1, you use the y initial plus the change in y. So the x1 is -1, and the change in x is 1, which equals 0. And the y initial is -3, plus the change in y, which is 1 times 1, which equals -2. The next step is to use the second point, 0, -3, and plug it into the same equation used in the last part. You then find that 0 plus 1 equals 1, and -3 plus 1 times 1 equals -2. Then you repeat the step again, and you find that for the third x, 1 plus 1 equals 2, and for the third y, -2 plus 1 times 1 equals -1, making that when x is 2, y is -1. The second question is to use Euler's method with a step size of 1.5 to approximate f of 6.5. The initial x's are provided in the question in a table that shows that we have 2, 3.5, 5, and 6.5. It also shows the derivative of x, which is 3, 2, 1, and -1. To find f of 6.5, we will use the same equation from the last problem, yn plus 1 equals yn plus the change in yn. For the first point, 2, -1, you use the equations that were used in the last problem to find that the x1 is 3.5 and the y1 is also 3.5. To find the second point, you use 3.5 and 3.5 to find that x2 is 5 and y2 is 6.5. Finally, you use the third point, 5, 6.5, to find that f of 6.5 is 8. The third question is dy over dx equals x minus 2y plus 2, and f of 0 equals 2. Using the same equation, we find that the first point is 0, 2, and you find that x1 equals 1.2 and y1 equals -0.4. The second point is 1.2, -0.4, which finds that f of 2 is 4.4.